Differentiation formulas. Let's use the formulas and solve a few problems. We do have a few differentiation formulas. Derivative of the constant is 0. Derivative of the power rule is defined by this formula. Constant multiple, derivative of the sum of the function, derivative of the difference, derivative of the product rule, and derivative of the quotient. That means I'm going to use all of these formulas. You can pause the video and you can always come back to that slide. That's our reference page. We also have a trigonometric functions and their formulas. Derivative of sine function, sine of x, cosine of x, tangent of x, cosecant of x, secant of x, and cotangent. All of the formulas we should memorize and apply at the right moment. Exercise number 1. Evaluate the limit. Limit as h approaches 0, quantity 2 plus h to the power of 10 minus 1024 over h. Of course, we don't really want to evaluate this limit algebraically. We would like to use some concept. That means we can see right away that this limit represents the derivative of the certain function at the point 2. And the function looks like quantity a plus h to the power of 10, which is x to the power of 10. Since this is derivative of the function x to the power of 10 at 2, we may use the shortcuts. We may use the power rule to get the derivative and then substitute 2. One more thing, we know that in the limit definition of the derivative, this quantity is f of 2, which is supposed to be 2 to the power of 10, and I believe this is 1024. Okay, correct. Okay, let's come back to this. X to the power of 10, derivative is 10x to the power of 9. And now I need the value at 2. 2 to the power of 9. And theoretically we can leave it like that, or maybe we can try to simplify. 10 times, since 2 to the power of 10 is 1024, I have to divide by 2 and I will get 2 to the power of 9, 512. Multiplying 512 times 10, we're just adding 0. That means this is the final answer. This limit is defined as a derivative of x to the 10 at 2, and the final answer is 5120. Let's do one more like that. Evaluate the limit. Limit as h approaches 0 of 1 over the quantity 3 plus h to the power of 4 minus 1 over 81 over h. We can see that this limit represents the derivative at 3, and the corresponding function is 1 over a quantity which is x to the power of 4. First of all, let's find derivative and then substitute 2. That means this is my quantity a, and this value is f of a. If we remember, f of a will be 1 over x, however, 3 to the power of 4, which 3 to the power of 4, it is 81. Okay, everything works. Let's rewrite function 1 over x to the power of 10 as a x to the power of negative 4, and now let's differentiate. Negative 4, x to the power of negative 4 minus 1. It is negative 4, x to the power of negative 5. Let's rewrite as a negative 4, x to the power of 5. And then we need a value at 3. Negative 4, 3 to the power of 5. Again, we can leave it like that, or we can try to get the answer. Of course, no calculators. 3 to the power of 4 was 81, and times another 3. 81 times 3, 243. This is the final answer. That's the value of the derivative at 3. And we can see we did combine concept and the limit definition of the derivative and the shortcuts, the power rule. Exercise number 3, we have a function and we have to find the derivative. 4 times root x times quantity 1/4 minus x squared. It looks like we have a product. We have to use the product rule, or I will try to distribute 4 root x and avoid the product rule. 4 root x times 1/4 is just root x. 4 root x times x squared is simply 4x squared root x. One more simplification. This is square root of x, and this one is x to the power of half and x to the power of 2. 2 plus half is 5/2. Now let's differentiate. Derivative of the square root of x is 1/2 root x. Derivative of x to the power of 5/2 is 5/2 x to the power of 3/2. We subtracting 1. Okay. Let's simplify. 1/2 root x minus, we can simplify 2 and 4. 2 times 5 is 10. That means we do have 10. And x to the power of 3/2 is square root of x cubed. 1/2 square root of x cubed, I can simplify like that, x root x, and possibly I can get a common denominator. We don't have to. I believe this will be the final answer, but just in case, for the multiple choice option, let's get the common denominator, which the common denominator is 2 root x, and I will multiply and divide by 2 root x, the second quantity. So we do have 1/2 root x. 2 times 10 is 20. X times root x times root x is x. Root x times root x is x, which is just x squared. Let's rewrite on the one fraction bar, common denominator, 1 minus 20 actually, x squared. That means I believe this is a nice final form. So make sure that you know how to use a few algebra steps, arithmetic steps, and get this form. Okay? Exercise number 4. Differentiate a function sine of x over 1 plus cosine of x. This one we can't really simplify. That means we have to use the quotient rule. Quotient rule is telling me that I have to take the derivative of top times the bottom expression minus top times derivative of the bottom denominator prime, all over function from the denominator squared. Let's see. Derivative of sine of x is cosine of x times 1 plus cosine of x minus sine of x. Derivative of 1 is 0. Derivative of cosine of x is negative sine of x. 1 plus cosine of x squared. Let's simplify. We have to distribute cosine of x times 1, cosine of x times cosine of x. Cosine of x times 1 is cosine of x. Cosine of x times cosine of x is cosine squared. Negative sine of x times negative sine of x is positive sine square of x. 1 plus cosine of x squared. And we can nicely see Pythagorean identity. So we do have on the top cosine of x plus 1. In the denominator I have cosine of x plus 1 squared. This means that I can simplify one of those. The final answer is 1 over cosine of x plus 1. Exercise number 5. For the function sine of x times cosine of x, find the derivative at pi over 6. The same thing, I can't simplify, I have to use a product rule. Derivative of sine of x times cosine of x plus sine of x derivative of cosine. F prime of x equals derivative of sine of x, cosine of x times another cosine, sine of x, derivative of cosine, negative sine of x. Okay, that's mean cosine of x times cosine of x is cosine square of x. Positive and negative sign will give me negative sine square of x. Okay, that means this is derivative. If we recognize, I am not sure if you do recognize, but this formula represents cosine of 2x. But we don't have to at the moment play with all of these identities. This is still correct answer, but cosine square of x minus sine square of x is cosine of 2x. Double angle formula for cosine. But let's use the blue box, and now let's substitute pi over 6. Cosine of pi over 6 squared minus sine at pi over 6 squared. Cosine at pi over 6 is square root of 3 over 2, and sine at 1/2. Square root of 3 squared is just 3, 2 squared is 4, 1/4. The final answer is 2 over 4, which is actually half. That's the final answer. Okay. Exercise number 6. Find the derivative of the function. Rational function 1 minus x squared over 1 plus x squared. And this is multiple choice. Let's see if we can get one of those options. I believe one of them is correct. Looking at the function, we can't simplify. We have to apply the quotient rule. Let's see. Derivative of the top function, I can maybe write right away. 1 minus x squared will be negative 2x times derivative times the function from the denominator. Or I can possibly write for you. Just, okay, quotient rule. 1 minus x squared. Derivative of this times the function from the denominator minus function from the top times derivative of the denominator. All over denominator squared. Okay, let's see. Derivative of the numerator is negative 2x times 1 plus x squared, and derivative of 1 plus x squared is 2x times 1 minus x squared. I just changed the order. And 1 plus x squared squared. Let's distribute this and this. Negative 2x times 1, negative 2x. Negative 2x times x squared, negative 2x cubed. Negative 2x times 1, negative 2x. Negative 2x and negative x squared, positive 2x cubed. And denominator squared. And I see negative and positive, the same quantity, opposite sign. Negative 2x and another negative 2x, negative 4x. 1 plus x squared squared. That's the final answer. And I hope I can see this on one of the options, C. Okay, exercise number 7. Actually similar thing. We can't simplify a function x plus 1 over x minus 1. Looking at the derivative, we have to use the quotient rule. Derivative of the top is 1 times the bottom minus top function times derivative of the bottom 1. Bottom denominator squared. Multiplying by 1, we're not changing anything, x minus 1. Now we have negative that has to be negative is, this negative is affecting both items inside the parentheses. Negative x minus 1. Multiplying by 1 is not changing anything. That means please remember especially this. That's the common mistake. We have some cancellation, negative and positive. Negative 1 and negative 1 is negative 2 x minus 1 squared. That's the final answer. And I believe one of the option is like that. I can't see. Yes, that's the final answer. Exercise number 8. If h of x is defined as a x times g of x, and it is known that g at 3 is 5, g prime at 3 is 2, find h prime at 3. Okay, function h of x is defined as a x times g of x. In order to find the derivative, I will use the product rule. Derivative of x is 1 times g of x plus x times derivative of x. And now let's substitute 3. 1 plus times g at 3, 3 times g prime at 3. 1 times g at 3 is just g at 3. G at 3 looks like it's 5 plus 3 times g prime at 3 is 2. 6 plus 5 is 11. That's the final answer. 5 plus 6, 11. Okay, another question like that. Product rule. Function h of x is defined as a square root of x times g of x. G at 4 is given, g prime at 4 is given, 8 and 7 respectively. Find h prime at 4. Let's find h prime of x. Product rule. Derivative of square root of x is 1 over 2 root x. Please remember, in order to differentiate square root of x, we may apply, or I can say we should apply, a power rule. Derivative of square root of x means derivative of x to the power of half. Product rule is power rule is telling me that I have to put 1/2 here, 1 x to the power of 1/2 minus 1. 1/2 x to the negative half. And if I will rewrite without the negative exponent, x to the negative half goes to the denominator and is square root of x. That means it's really worth to remember derivative of the square root of x. We can always use the power rule, but it's just worth to remember because it's the frequent function. Okay, again, square root of x derivative is 1 over 2 square root of x times the second function plus first function times derivative of the second. Now let's just put the value 4. 1/2 square root of 4 times g at 4 plus square root of 4 g prime at 4. 2 times 2 is, square root of 4 is 2, 2 times 2 is 4, g at 4 is 8, plus 2, g prime at 4 is 7. 2 plus 14, it is 16. That's the final answer. Okay, similar, but now we will test a quotient rule. H at 2 is 4, h prime at 2 is negative 3. Find derivative of the function h of x over x. That means derivative, we have to use, at 2 of course, we have to use the quotient rule. derivative of the top function times the bottom minus the top function times derivative of x, 1, all over x squared. And now we have to substitute x equals to 2. H prime at 2 times 2, h at 2 times 1, I can of course skip it, 2 squared. H prime at 2 is negative 3 times 2 minus 4 over 4. Negative 6 minus 4 over 4, negative 10 over 4, negative 5 over 2. That's the final answer. Quotient rule. Exercise number 11. Multiple choice. Let's see. Suppose that h of 2 is 3. H prime at 2 is negative 1. Find the slope of the tangent line M to the graph x squared plus 1 times h of x at the point 2, 15. That means we know that the slope of the tangent line, it's simply a derivative of the function at the given point, which the given point is 2, 15, the x coordinate is 2. That means let's find the derivative. We have to, that's the slope. That means function is defined as a x squared plus 1 times h of x. This means derivative is like that. I have to use the product rule. Derivative of x squared plus 1 is 2x times h of x plus x squared plus 1 times derivative of the second function, which I can only write h prime of x. And now I have to substitute 2. 2 times 2, h at 2, plus 2 squared plus 1, h prime at 2. We can see that's 2, that's 2, that's 2, and this is 2. And let's find. 2 times 2 is 4. H at 2 is given, and it is 3. I did cross it. And 2 squared is 4, plus 1 is 5, and h prime at 2 also is given, is negative 1. This means derivative at 2 of the given function, which is the slope of the tangent, it's 12 minus 5. It is 7. Slope. Of tangent line. And we do C7. I can box my final answer. I can write also M. Okay, exercise number 12. Suppose that f is differentiable function such that f of 2 is 12, f prime at 2 is 8. Again, the same question. Find the slope of the tangent line to the graph of h of x, but h of x is defined different, f of x over x squared at the point 2, 3. Okay? That means now we have to probably practice quotient rule. Okay, slope, it's simply a derivative of the function. Yes, slope, actually we're looking at h, to the function h. Okay, and this is function h, f of x over x squared. Let's apply a quotient rule. Derivative of the top function times denominator minus top function times derivative of the denominator, which derivative of x squared is 2x, all over denominator squared. Okay, let's put right away the value of x2, because this is telling me that everything is happening at the point 2, 3, which x coordinate is 2. Let's substitute. F prime at 2 times 2 squared minus f at 2, 2 times 2, and 2 squared and again squared, which of course will be to the power of 4. f prime at 2, I need the value f prime at 2 is 8 times 4 minus f of 2 is 12 times 4, and 4 squared is 16. Let's see. We can produce numbers, or we can do some tricks. I can factor out 4. We can of course multiply, and we can divide. I think we can still find a common factor. 8 minus 12 is negative 4 over 4. The final answer is negative 1. That's the slope of tangent. Line at x equals to 2. Okay, this is slope m. Of course, we can, what I can do, we can still say 32 minus 48 over 16, which is negative 16 over 16 is negative 1. I just wanted to avoid big numbers, which actually 32 and 48 is not huge numbers. Okay, negative 1 is a slope. And the quotient rule? Exercise number 13. Multiple choice. Okay, find the x-coordinate or coordinates of the point on the curve y equals to x minus 1 over 2x, where the tangent line is parallel to the line y equals to 3x minus 2. We know that if the lines are parallel, slope are the same. Slope of this line is 3. That means slope of tangent must be 3. And slope of the tangent is simply a derivative. Let's take this function and find the derivative. Derivative of x is 1, and derivative of 1/2, let's maybe do on the side, and then I will come back. That means my function is defined as a x minus half x to the negative 1. Derivative of x is 1 again. Derivative of 1/2 x to the negative 1, it will be like that. 1/2, copy 1/2, and then negative 1 x to the negative 2. 1, negative and negative is positive, and x to the negative 2 is x squared in the denominator. So we did compute a derivative. Let's substitute. Derivative is 1 plus 1 over 2 x squared equals to 3, because derivative is the slope of the tangent and must be 3. Let's subtract 1 from both sides, and let's cross multiply, and let's divide by 4, and let's take a square root of both sides. Positive and negative half. That's the x values that satisfy this equation, which means slope is 3. Tangent line will be parallel to the given line. Tangent line, of course, to that curve. That means slope is positive and negative 1. We can also, we have to be really careful, because both of the numbers are in the domain. We can see this function has the domain. We can accept all of the numbers except 0, because 0 is. But I didn't get 0. That's the reason that I am accepting both of the numbers. And remember, taking a square root, always positive and negative. Okay, exercise number 14. Oh, nice and short. Derivative with respect to x of 3 pi squared equals to 6 pi. True or false? Of course, false, because this is a constant. Derivative of the constant is 0. Okay? Derivative of the constant is 0. Constant. And derivative of constant, of course, is 0. That means it's not 6 pi. Question number 15. At what points on the hyperbola xy equals to 12 is the tangent line parallel to the line? Okay, that's we know again that the parallel lines has the same slope. Slope of this line looks like it's negative 3. That means I want slope of tangent, since they have to be parallel, must be negative 3. And I also know that slope of the tangent to the hyperbola, it's simply a derivative. That means derivative must be negative 3. Let's compute the derivative. No? This is hyperbola xy equals to 12. Let's solve for y, 12 over x. That means derivative will be negative 12 over x squared. It's 12 and then derivative of x to the negative 1, which we just did here. X to the negative 1, it's negative x to the negative 2, which is negative 1 over x squared. I can possibly write this, because this is also one of the frequent function, 1 over x derivative with respect to x is negative 1 over x squared. Power rule could be applied. Okay, that means this is, we do have derivative of our function, and let's plug in negative 12 over x squared equals to negative 3. We can cross multiply negative 3x squared equals to negative 12. We can divide by negative 3, and we can take the square root, plus or minus 2, positive and negative 2. That's the points. Also, domain was all of the numbers except 0. That means if I will get 0, I can accept all of these numbers. At 2 and at negative 2, we will draw a tangent and will be parallel to the line negative 3x. Slope will be negative 3. And I do have graph. Let's see. And we can see this is negative 2 and this is positive 2. The yellow line is the given line and both of the pink are the tangent lines and they are parallel. Exercise 16. Let function p be defined as a f times g times q is defined f over g, where f and g are the functions whose graphs are shown. Okay, f is the pink one and g is the green or blue, I think greenish. And this is xy plane. Okay, we can try to have scale 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Okay, now find p prime at 2. P prime, first of all, at x. I have to look at this function and use the product rule. F prime at x times g at x plus f at x times g prime at x. Now we're looking for p prime at 2. Let's put 2. F prime at 2, g at 2, f at 2, g prime at 2. Now we have to recover a values from the graph. That means, let's see. I will need f prime at 2. F prime means the slope of the curve or the slope of the tangent at 2. That means this is 2. That's the corresponding point on the f, and if I will draw a tangent, will be horizontal. Slope is 0. That means this is 0. G at 2 is simply the value of the function g at 2. 2 corresponds to 2. Plus f at 2 is just the corresponding value, which will be 3, times g prime at 2 is the slope of the tangent line at 2 for the function g. That means that's the corresponding point, and if I will draw a tangent, it will be like that. What's the slope of this line? Rise over run. I can draw on this side 2 and 4. 2 over 4, which is half. Okay, please remember, I can circle. That's the boxed. That's the slopes of the tangent because they are derivatives. Okay, and let's get the final answer. 0. Actually, I can just write 3/2. Okay, now we do have similar situation, but we have to investigate situation at 7. But function is defined, the q function is defined as a f over g. Okay, q prime at x, quotient rule. This is f over g. That means derivative of f times g minus f times derivative of g, all over function from the denominator squared. Okay, 7. Let's see if we can get f prime prime at 7, just g at 7, f at 7, g prime at 7, g at 7, and squared. Let's check the values. F prime at 7, it will be a tangent line for the function f at 7. This is 7, and that's the corresponding point, and looks like it's this line. I can even highlight the entire line. This line has the slope. Actually, I can use this. How many units? 1, 2, 3, 4, 1. 1 over 4. That means this is 1/4 slope. Okay, please remember that's what I'm doing. That's the slope of the tangent line. And g at 7 is just the corresponding value. G at 7 corresponds to 1. Minus f at 7, let's check. F at 7 corresponds to 5. Okay. And g prime at 7 is a slope of the tangent line. That means that's the corresponding point, and tangent line is that line, which I can make it longer. And slope I can compute as a -2, 3. -2 over 3, because it's getting down. -2 over 3. This is slope. Please remember, it's not a value. Derivative on the graph means slope. Okay, and the value of the denominator is the value of 7, which was 1 squared, which we can ignore it. Okay, it is 1/4. Negative and negative is positive. 10 over 3. We can try to get the common denominator, which this will be 12. 1 times 3, 4 times 10. 43 over 12. That's the final answer. I'm just trying to double check, but I believe it's 3 and 40. And negative will give me positive. Okay. Exercise 17. For what values of a and b is the line 2x plus y equals to b tangent to the parabola y equals to ax squared when x is 2? Okay, that's what we have. We do have a line 2x plus y equals to b, and this must be a tangent. That means if this is tangent, -2x plus b, that's b, it's telling me that the slope of the tangent is -2. Slope of tangent is the same like slope of this line, which is -2. We also know that the slope of the tangent, it's simply the derivative. Derivative of this function, ax squared, is 2ax. And we know that everything is happening at 2. That means x equals to 2. I can substitute instead of x 2, and I can solve this equation for a. Negative 2 over 4, negative half. Excellent. That means my function is negative half x squared. Okay. And my tangent line is negative 2 plus b. Okay, that's the function and that's the tangent. We also know that function, that's the function, and its tangent, they do have a common point. That means the values, negative half x squared, they have to be the same at the point of the tangency, of course, at the moment that x is 2. Again. Okay, they have to be the same. That we can see we did create a nice equation. Let's substitute instead of x2 and solve for b. Negative half times 4, negative 2 times 2 plus b. Negative 2, negative 4. That means I believe b is negative 2. That's the final answer for b and final answer for a. Exercise 18. Find the value of c such that the line y equals to 3/2 x plus 6 is a tangent to the curve. Okay, similar situation. Slope of the tangent is just the derivative. If this is tangent, the slope of this line is 3/2, which must be the same like slope of slope of the tangent, which is the derivative. Okay, c square root of x. Derivative of this is copy a constant. Derivative of the square root of x is 1 over 2 root x. And find the value of c. Okay, we will try to find the value of c. First of all, what we can do, I can simplify this equation. Okay, let's solve. I can cross multiply 2c equals to 6 root x, c equals to 3 root x. Okay, I do have a c value, but I don't know what is my x value like the previous problem. That means I have to probably use the same equation that I did. Since the curve c root x has one common point with its tangent, we can find this point. 3/2 x plus 6. And I know that c is defined as a 3 root x. I just get this from my concept. Okay, I can draw a little bit nicer. Okay, that means substituting 3 root x instead of c, I'm getting 3 root x times root x, which I'm getting 3x, and 3/2 x plus 6. 3 minus 3/2 is actually 3/2. Oh, no, equals to. And then x equals to 4. Because if I multiply by 2, 12, divide by 3, 4. Okay, that means the question was find the value c actually. That means combining these two, c is 3 root 4, because I have to substitute everything it's happening at x4. 3 times 2, 6. The value of c is 6. This is the final answer. And I do have one more question. Which of the given function is not differentiable at 0? That means this one, I don't know if we really, probably we need some formulas, but let's test like everything what we know so far about the derivatives. That means we have to find which function f, g, or h is not differentiable at 0. What we can do, let's start with the function f of x. F of x is defined as a absolute value of x squared minus 1. That's me. Let's try to do graphically this question. I will try to get the graph of this. And we know that graph of function like that, first of all, I have to get a function x squared minus 1. That means function x squared minus 1 is just a parabola shifted 1 units down. No? I think it's -1, -1. But since I'm taking absolute value, we know that absolute value, if it's positive, stays the same, positive. I can use different color. That means everything what was above the x-axis is positive. Everything what was below, which means absolute value of negative numbers, becomes positive. That means this is the graph. The blue graph is the graph of my function f of x. And I can possibly remove this. Okay, and we can nicely see that at derivative at -1 of the function f and at 1 is undefined because we do have these sharp corners. At 0 we have nice horizontal tangent, and derivative at 0 is also 0 because slope is 0. That means this function is actually differentiable. That means this is not my option. Okay, we can see we can all three functions. That means that's also we can remove a and c because this function f is definitely differentiable. Okay, that means this is the first one. Let's check the other one. The other function, x to the power of 2/3. X to the power of 2/3, cube root of x squared. This one is also one of the fundamental function, and I will just recommend to know the graph. That's we do have a few graphs in mathematics. Let me draw a little bit better that we supposed to know the graph. That's mean function looks like this and this. This is x to the power of 2/3, cube root of x squared. And we can definitely see that at 0 we do have a sharp corner. Derivative at 0 is undefined. We can also try to find the derivative. We can see that function is defined everywhere because cube root can take all of the numbers. That means domain is all of the numbers. But if I will take the derivative, 2/3 x to the -1/3, let's rewrite without negative exponent 2, 3, cube root of x. I see that my derivative has x in the denominator, which means this derivative is not defined at 0. It is an important number. Okay, we know we will learn what this is quite important number, but it's not defined at 0. That means this is my answer. I mean, G is definitely my answer. Okay, and let's investigate the other one, the last one. X squared h. Function h of x is defined as a x squared sine of 1 over x, and this is defined everywhere but not at 0, but the value at 0 is actually 2. Okay, that means value of the function at 0 is 2. Now we have to check if this function is continuous function, because we can definitely see that close to 0 function is defined as a x squared sine of 1 over x. That means we can try to check the behavior as x goes to 0. And probably we remember that this limit using the squeeze theorem is 0. I can solve it for you. Sine of 1 over x. Actually, sine of any angle is defined between -1 and 1. If I multiply each side by x squared, I will have this. Okay. And then as x goes to 0, the parabola negative x squared goes to 0. Parabola positive x squared goes to 0. of course, as x is approaching 0, then the middle function is also not differentiable at 0. I can write h prime at 0 does not exist. That means this is also a correct answer. And G and H are not differentiable. Okay, that was quite a challenge question, but I think was good.